Good evening, all.
Good evening, sir.
Yes, good evening, everyone. We will wait for 2 minutes and then we will start. Okay?
Good evening, sir.
Yes. Good evening. Good evening.
Good evening, sir.
Good evening. Good evening, all. Once again. So I will share my screen. Please let me know if it is visible. Is my screen visible?
Yes, sir.
Yes.
Okay, so I think we can start now. About yesterday's learning, can we have a short recap? Hello.
Yes, sir.
Can any one of you please tell me about your yesterday's learning?
Sir, yesterday we learned about the checklist. Then uh,
Okay, we started with that some flowchart symbols. So I added two or three flowchart symbols and we started with that. Then we saw
that
one example of flowchart used in industry, correct? So we started with that. So receiving order flowchart and some symbols we studied. After that, we moved to the check sheet. Clear? What is check sheet?
Yes.
so the check sheet is used to collect the data in real time at the source of like Gimba
Okay,
and
so check sheet is a data collection tool. Okay, it is a very simple tool. Even operator, analyst, your engineer, supervisor can use that tool. It is a very simple tool. It is a visual tool and it doesn't require any statistics. But what are the steps? We need to select which data we are going to collect. For example, defect data, machine stoppage data, machine breakdowns data. Then we need to prepare a trial check sheet and we need to train somebody. If suppose X person is going on the shop floor to collect the data for me, then I need to train him or her. I will explain what data he needs to capture and then I can capture the data in the form of check sheet, right? So it is a very simple tool. Yesterday we saw the check sheet used at home, that is the newspapers, food order and milk bags, correct? Are you getting or not?
Yes, sir.
Yes, sir.
Yes, so we started with this check sheet history. Who developed this check sheet? Walter Sheward developed this check sheet, and he used it to gather the data, particularly in manufacturing. Then this is a real-time data source, a structured form. It is very easy to interpret. It is easy to use. Then when to use check sheet? We can use check sheet during data collection. If I would like to grasp the present status of my defects, rejection, I can use the check sheet. When I would like to stratify the data, I can use check sheet. Also, I can use check sheet for the process monitoring, as well as I can use it for training the people. Then we saw how to make a check sheet. So we need to select a event, we need to define a purpose, then we need to decide the location and the time where the data will be collected, and we can decide the categories by place, by time, in which machine, on which plant, on which shop floor. And then I discussed make a trial format and train your person. It may be a supervisor or operator like that. Then these were the examples at home. These were the examples in industry. And also we saw the concentration diagram in check sheet. Okay. So check sheet is clear?
Yes.
Yes, sir.
Yes or no?
Yes, sir.
Yes, yes.
Yes. Then we saw the stratification. So stratification, some people are saying the flowchart is the 7 tool. Some people are saying the stratification. So we have decided we will study the both. So Karo Ishikawa introduced the stratification, and he used it to make quality controls more accessible to all levels, particularly the workers as well. And this concept is originated in Japan. What is stratification? It is strata means data, subgroup or group. So we need to divide data into subgroups, or we need to collect the data from the subgroups. For example, shift wise, machine wise, operator wise, location wise, city wise, country wise. So suppose if any multinational company wants to capture the sale country wise, then it is a stratification. So country wise data, shift wise data, operator wise data, machine wise data, location wise data. These are the examples of the stratification. And stratification always helps to unmask the true facts. So suppose that operator is the problem, then we can say that we need to train them or develop them, because currently operator is the problem, like that. Then when to use stratification? To identify the causes, to identify the sources of variation, and when we would like to get clues of a particular problem. I'm not saying in-depth analysis, but at least a clue, right? Then how to use it? We can regroup the original data from the source. These were the examples, machine-wise data, and this is the group A, group B. So I said that is contractor A, contractor B. So contractor A, group A, that is contractor A is doing good. So you can say to group B that this is doing good. So what are the problems in group B? Even though conditions are the same. So here machine 3 is the problem, even though other two machines are having less problem as compared to machine 3. Part is same, operator is almost same, and then machine 3 is problem. Clear? So we saw that. After that, we saw the 3G approach. What is 3G? Can anyone tell me what is 3G?
Sir, Genba,
Sir,
Genbutsu,
Ginga,
Genjitsu.
Genretsu, and Genjutsu.
So it is a Gemba, Gembetsu, and Genjitsu. What is Gemba?
Real place or real scene, meaning and description.
Real scene
Go to
means
the
real
place where
workplace,
it is
where
done.
the problem is occurred, where the problem is occurred or occurring. So whenever you
Sir,
identify a problem, for example, crack, so directly go to the Gemba. So that is called as first G. Now you need to go to the Gemba, for example, injection molding machine. So you need to go to the Gemba, injection molding machine. Then you need to check or observe the Gembetsu. Now I will hold the bottle which is having crack in my hand. I will observe the location, how big is the crack, how wide is the crack. So if there is a problem of that rejection part, I can take that part in my hand. I will observe it. Sometimes if there is a problem on machine, I will observe the machine, or if a particular problem of the machine, for example, gripper, extractor, I will observe those. That called as Gembetsu, that physical object, either a part, either a machine, or a part of machine. So that is called as Gembetsu. And what is Genjutsu? What is Genjutsu?
Real
Actual
it's a
facts, sir.
real fact. Real fact.
Checking,
Actual
Genjutsu
facts.
is a real fact.
checking
Okay,
of the real
Genjutsu
facts.
is a real fact. What you are observed. So I visited the Gemba, I checked the Gembetsu and I observed that Pokayeko is not working. I observed that sensor is not working. I observed that water is blocked and his dye temperature is high. I observed that molten metal temperature is high. Molten metal sensor is not working. So these are called as Genjutsu. And hence it is said that no opinions from offices, directly go to the Gemba and collect the actual facts. Clear? 3G concept is clear?
Yes.
Yes, yes, I will do it. For the Pareto, I will use it. Hmm? Can we proceed now?
Yes,
Yes,
sir.
yes.
Yes. So now we will go to the third tool that is called as fourth
Scattered
tool
diagram.
that is called as
Scattered diagram.
scatter diagram. Okay. So we will see the history of scatter diagram, and then we are going to plot this on Excel scatter diagram, and also we are going to plot the Pareto on Excel. Okay. So what is scatter diagram? So scatter diagram is, let's discuss about the history first. So there was a one coordinate system developed by Mr. Rene in 17th century. That system is called as Cartesian coordinate system. And it was just visualizing the data points. Where is my data is lying? If data is lying here, then it is a positive positive. When the data is lying here, it is a negative positive, like that. So this simple system is called as Cartesian coordinate system. All the mathematics is based on this four quadrant. But the modern scatter plot for analyzing the relationship between the variables evolved later. So before studying the scatter diagram, please let me clear. Scatter diagram is used for the variable data, means continuous data. So if there are two variables, means these two variables should have the continuous data. We can measure it on continuous scale. Then and then only scatter diagram is used. Scatter diagram is not used for the attribute data. And hence, on the day one, I clear the concept. What is attribute? What is the continuous data or variable data? So continuous data is called as variable data. Discrete data is called as attribute data. And we saw the continuous data means we can measure that data on a continuous scale, or this is called as variable data. So scatter diagram is used for the two variables. We should able to measure the data. So that is first, let me clear. Scatter diagram is always used for the variables. Okay. So the modern scatter plot for analyzing the relationship between variables, it is evolved later. John Herschel, who is credited with creating the first scatter plot in 1833. Now we are studying this in 2025. But first scatter plot was used by John Herschel. But this concept of scatter plot, it was popularized in 19th century and 20th century. So Francis Galton popularized in 19th century when he was working on the heredity. But the term scatter plot, which we are using commonly, it is used extensively in early 20th century, with Carl Pearson contributed to its formalization. So Carl Pearson contributed a lot for the scatter plot. So Francis Galton and the Carl Pearson, they contributed a lot for developing the scatter plot or scatter diagram. So once again, I will repeat. So scatter diagram is also called as a scatter plot. It is used for the variable data. It is used to analyze the relationship between variable data. Means if I have two data, for example, one data is temperature in degree Celsius and another data is the sale of ice cream. Suppose when temperature is 40, how much is the sale of ice cream per day? When the temperature is 45, how much is the sale of ice cream per day? So when I would like to analyze the relationship between two variables, one variable is sale of ice cream and one variable is the temperature in city. If I would like to analyze the relationship between two variables, then we use scatter diagram. Correct? So, and history is, it is popularized in 19th and 20th century. In 19th century, Francis Galton popularized this concept, but this scatter plot used extensively in early 20th century with the Carl Pearson. So, history is clear of scatter diagram. So, main 2 points. So, it is used to analyze the relationship. That is point number 1. And second is, it is used to analyze the relationship between the variable data. So, 2 points are clear. Data should be variable, means we cannot use the scatter plot for the discrete or attribute data. Is it clear?
Yes.
Please type yes if it is clear. We are using scatter plot only for the variable data. Clear now?
Yes,
Yes,
sir. Clear.
Yes. Now, what is scatter diagram? Scatter diagram is a graph. Scatter diagram is a graph of points where we are comparing two variables. And the pattern of points, I will show you some diagrams, then you will come to know what is the pattern of points. The pattern of points indicate the degree and nature of relationship. So that nature of relationship is called as correlation. So what is scatter diagram? Simply, it is a graph and it is used to compare two variables. And this graph or this plot or this diagram shows or indicates some patterns and nature of relationship. So this nature of relationship is called as correlation. So when we discuss one example, you will clearly know what is correlation, what is scatter diagram. Okay. And when to use scatter diagram? When we want to check the
analyze it.
relationship between two variables, whether they are
Analyze it.
interrelated or not. So when we want to check the relationship between two variables, we use scatter diagram, and it is used to estimate the strength of relationship. So whether it is a strong relationship, whether it is a moderate relationship, or whether it is a weak relationship. So in order to estimate the strength of relationship between two variables, we use the scatter diagram. So once again, I will repeat what is scatter diagram. It is a graph of points used to compare two variables. That is point number 1. And normally there are some pattern of points and there is some the nature of relationship between two variables, and that nature of relationship is called as correlation. So in order to understand the correlation between two variables, we use the scatter diagram. When to use scatter diagram? We can use scatter diagram to check the relationship between two variables and to estimate the strength of the relationship between two data. Means if the temperature of city is increasing, whether the sale of ice cream is increasing or decreasing, and what is the relation between them. And when the temperature of city is increasing, the sale of tea is increasing or decreasing. So what is the relationship between two data? So if one variable is increasing, for example, if sale of ice cream is increasing, when the temperature of city is also increasing, means it is called as positive relationship, because when x is increasing, y is also increasing. So that is called as positive relationship. And when x is increasing, for example, my temperature is increasing and my sale of tea is decreasing. When x is increasing and y is decreasing, then it is called as negative correlation. Clear? Once again, I will repeat. Scatter diagram is used to establish the relationship between two variables, So suppose x, one variable is increasing and y is also increasing, then it is called as positive relationship. As I given the example, if temperature of the city is increasing, the sale of ice cream is also increasing, then it is called as positive relationship. When temperature of city increasing, but sale of tea is decreasing. As temperature increases, the sale of tea decreases and the sale of cold drink increases, for example. Then it is called as negative correlation. So have you got the concept of positive correlationship and the negative correlationship?
Yes.
Yes.
Is it clear?
Yes, sir. Clear.
Okay.
Positive correlation, negative.
Now, here is the example and we will study the example through Excel as well. I am just putting figures. Please don't correlate with that. So it is just for your understanding. Suppose weight of the students, there are very small students. So weight of the students in kgs and height of the students in centimeters. So these were the two. These are the two variables. One is weight. We can measure weight on continuous scale, and hence it is a variable data or continuous data. Also, we can use. We can count. Sorry, not count. We can measure the height of the students in centimeter. So it is also a variable data. Now here I mentioned the weight of the students and here I mentioned the height of the students. So this is the data. For example, in my class there are 8 students and I mentioned the weight of these 8 students and this is the height of the students, for example. Now I need to establish a relationship between these two variables. And when I need to establish the relationship between two variables, I can use scatter diagram or scatter plot. So how to draw it, we will see through Excel. So for example, after plotting in Excel, this graph looks like this. Okay. Let's go to the Excel where I will plot this example and then we will discuss what is correlation. Okay. So now I will go to the Excel file. So is my Excel screen visible?
Yes, sir, it's visible.
Visible, na? Yes.
Yes, sir, yes, sir.
Yes, sir.
Okay. Now I have plotted the figures, weight of the students and height of the students, and I need to plot the scatter plot. Okay, now I will select the data. Okay. So here are the scatter plots. This is mentioned scatter. So I will just enter. So I will get this data. Okay. I can adjust the scale. For example, format axis, I can adjust the scale. Suppose the minimum is I can put on y-axis, for example, 40. Enter. Or I will put 50. Okay. Or even I can put 60, I think. Okay. And on x-axis, minimum is, for example, 10. Okay. Now the graphs looks like this. You can put the chart title, height and weight of the students. Okay. So now this is the scatter diagram. So this is showing when, for example, height increases. So I can give the name to this axis as well. So you can do it later on. Value addition. When we are observing that when height of the students is increasing, this is the weight. So weight of the students is also increasing. So as I told you, when x increases, Y increases, this is called as positive correlation. Okay. So this is called as positive correlation. Is it clear? So this is the weight of the students and this is the height of the student. When height is increases, weight is also increasing. This is called as scatter plot. Okay. Now here I mentioned the correlation. So how to calculate correlation? I will let you know. So we can use the formula. So I have already used it for your reference. Correlation is equal to CORREL, correlation of array this. I need to select this. You can practice it. Then I need to select this and enter. So correlation, that correlation is denoted by the letter small r. So that correlation is 0.99. So I will let you know what does it mean. Correlation is denoted by the letter small r. It is 0.99. So this is the one example, height of the students and weight of the students, correct? Now, this is the second example. So, sale of the ice cream and temperature in degree Celsius. So, suppose if there is a one shop in Pune and that shop, suppose the temperature of Pune in 20 degrees Celsius on that a particular day, for example, the sale of that ice cream in rupees is 30,000 like that. When the temperature is 25, 34. When the temperature is 30, 41. And when temperature is 45, it has the highest sale of 80,000. So I have this data. Now I need to plot a scatter plot. Okay, so what I will do, I will select the data. I will go to the insert. So this is the scatter plot. Okay, once again, I can do the format axis. Suppose minimum is 15. And here minimum is 20, for example. So this is my scatter plot. You can name it. Huh? You can name it later on. So this is my scatter plot. This is my scatter plot. Now I can find the correlation. Correlation is denoted by R. I will let you know what that correlation means. So now correlation formula is correlation is equal to CORREL. This is one and this is another data. So correlation is 0.98. Clear? So correlation is 0.98. Similarly, I plotted the scatter plot of sale of tea in rupees and temperature in degree Celsius. I use the same diagram and this diagram is look like this. What does it mean? When the temperature is increasing, so here is tea, it is a sale of tea. So what does it mean? When temperature increases, the sale of tea decreases. So now this is called as negative correlation because when X increases, Y decreases. So is it clear how to plot scatter diagram? It is very simple. Just select the data. Once again, I will let you know. Just select the data. Insert. These are the scatter plot and then you can adjust the axis and then you can find the correlation by using the formula. Correlation is equal to this array, this data, comma, this data, and I enter. This is the correlation. So correlation here is the minus 0.9 and early here is the 0.98 plus 0.98. Okay. Now I will come back to the presentation. Okay. So it is clear now how to plot it. Clear? Was it visible? Was it understood?
Yes, sir, it is understood.
Okay.
Yes, sir. Understood.
So now we will discuss what is a negative correlation, what is that. So here R value was 0.98. Now what does it mean? We will discuss. Okay. So before that, I would like to introduce some of the patterns of scatter diagram. So there will be, for example, these are the 5 patterns. For examples, when the points are distributed like this, it means there is no correlation. These are X and Y, there is no correlation. Means they are not dependent on each other. So there is no correlation. Okay. So this is called as, it is a possible negative correlation because when Y increases, X decreases. So I will use a pointer. So when Y increases, X decreases. So this is the negative trend. So it is called as possible negative correlation. Why negative? Because when X increases, Y decreases, or when Y increases, X decreases. And it is called as possible negative correlation. Why the word possible? As compared to this, there is a strong relationship, but I will let you know the perfect relationship. So this is called as possible positive correlation. Means when X increases, Y also increases. This is called as positive correlation. This is called as negative correlationship, but possible negative, and this is a possible positive. But when the dots are very near to each other, very, very near to each other like this, and when Y is increasing, X is decreasing, and dots are very close to each other, then it is called as strong negative correlation. Why it is a strong? Because points are very close to each other. Why it is a negative? Because when Y increases, X decreases. Clear? This is called as strong positive correlation. Why strong? Because points are very close to each other. Why positive? When Y increases, X increases. So this is called as strong positive correlation. So scatter diagram patterns are clear.
Yes.
Yes, sir.
Okay, let's go to the next slide. So here it is more clear. Now I will explain here the R value. Okay. Now, as I told you, when we call the correlation, so we are getting the values of R. For here, very perfect positive correlation because points are very close to each other, and when Y increases, X also increases. Here R will be 0.95 or 1. So always remember R varies from -1 to 1. R varies from correlation coefficient, or correlation varies from -1 to 1. When it is a 0.9 or 1, then it is a perfect positive correlation. When R is 0.8 but plus 0.8, it is a plus. So it is a highly positive correlation. Okay. When R is 0.3 to 0.5, then it is a very low positive correlation. Positive correlation because when X increases, Y is increasing, which is very low because R value is 0.3. Now let's see the diagram number 4. Here is no correlation at all. R is equal to 0. Here R is equal to minus 0.3 to minus 0.5. It is a minus. Why? Because it is a negative. When Y increases, X decreases, it is a negative correlation. But it is a low negative correlation. When R is 0.8 like that, minus, when it is a highly negative correlation, and when R is minus 0.95 to minus 1, then it is a perfect negative correlation. So this is called as scatter diagram. And depending on the value of R, we can say whether it is the positive or negative. When R is positive, it is a positive correlation. When R is negative, it is a negative correlation. But when R value is 0.3, so it is a low positive correlation. When R value is minus 0.3, it is a low negative correlation. When R value is 0.7 to 0.8, it is a highly positive correlation. When R value is minus 0.7 to minus 0.8, it is a highly negative correlation. When R value is 0.9 or 1 positive, then it is a perfect positive correlation. When R value is minus 0.9 to minus 1, then it is called as perfect negative correlation. Got it? Please look at this diagram once again. Please understand, depending
Sir,
on R value, how we are treating it. Either we are treating it as a perfect positive correlation, perfect negative correlation, low positive correlation, low negative correlation, highly positive correlation, highly negative correlation, or no correlation at all. Okay.
sir,
Now I will again, yes,
sir, how can we find low positive correlation?
pardon.
How can we find low positive correlation?
So I will go to the Excel. When Excel, for example, here, you can just use this correlation.
Okay.
Suppose you can just plot your data, and if R value is like 0.3 plus, here it is a minus 0.98, means it is a highly positive, highly negative correlation.
Negative correlation.
Depending on your R value, you can treat. So you can just put your data in these columns, just plot the scatter plot, and depending on the value, you can declare it whether it is a positive, negative, it is a strong, medium, or low. So it depends on your data. I am again telling, suppose you put this data and you use this formula of correlation. I am again writing out the formula. Formula is CORREL. This data, comma, this data. So this data and this data, and the R value is minus 0.98. So value is minus means first I understood that it is a negative correlation. Very good. So now it is a 0.92. So I can say 0.95 to 1 is a perfect. So it is a very high, because above 0.9 it is a very high negative correlation. Clear? So depending on this
Yes, sir.
data, now tell me here R value is 0.98 in this case. Sale of ice cream in rupees and temperature in degrees Celsius. Now what you will say about this? Value is positive or
Highly
negative
positive
first?
correlation.
Positive
First,
correlation.
value is positive or negative?
Positive.
Positive.
So means clearly it is a positive relation. Clear?
Perfect
Positive correlation, sir.
correlation.
Yes. But what is the value? 0.98. So it is greater
0.98.
than 0.9. It is greater than 0.9 or 0.95 to 1. Then it is called as
Perfect.
perfect positive
Perfect.
correlation.
Correlation.
So what should be your conclusion? Your conclusion is the sale of ice cream in Pune city and the temperature in degrees Celsius and Pune city are positive correlated, or highly positive correlated, or having a strong positive correlation. What does it mean? It means when the temperature of the city increases, definitely my sale is going to increase. Suppose I am an ice cream shopkeeper and I collected my data of my shop floor. My shop. I plotted scatter diagram, and suppose there is a prediction that in next week the temperature will be at the highest level in Pune city. It is near about 40 degrees Celsius. Then I need to assume that my ice cream sale will be high, and accordingly I can purchase a stock. For example, the sale of tea in Pune city versus temperature. Suppose my temperature is going to very high, in 40 degrees Celsius in Pune. Then as a shopkeeper, I need to assume that my sale will be very less, because it is a negative correlation. So that this scatter diagram help you to take a decision based on the R value and whether it is a positive or negative. It is a negative, it is a negative correlation. It is a positive correlation. Clear?
How is it significant in quality control?
Yes,
Pardon?
sir. Sir, one question, sir. Sir, regarding the
Yes.
scatter diagram, What is
Yes.
the impact in QC, sir? Quality control, where this scattered diagram actually implies, sir.
Yes. So, why I'm given generic example, because people are for different industries. When to use scatter diagram, I will. For example, suppose this is the scatter diagram of industry.
Yes.
Percentage of rusty jobs and humidity in percentage. For
Okay, sir.
example, humidity increases and suppose my percentage of rust increases. Now I need to plot a scatter diagram and my R value is 0.94. What does it mean? In quality, I can take a call that when humidity will increase, I will get more rejection of rusty jobs because there is a strong positive correlation. Now I will let you know how to use in quality. Now what you can do is make a square of R. So make a square of R. So it is 0.88. So now I will tell you, when you make the square of R, it came 0.88. What does it mean? Means 88%. I can say that percentage of rust is because of humidity. So I'm not 100% the rust is because of humidity, but 88% rust jobs is related to the humidity. Clear? So I can
Yes.
predict that 88%, I can say that percentage of the reason for the percentage of increased rust is the increase in humidity. Clear? Suppose
Yes.
if suppose I value is zero point 0.7. For example, my R correlation value is 0.7. When I make the square of this, so this 0.7 into 2, 49 means I can say that 50%. Suppose value is instead of 0.94, it is a 0.7. I can predict that 50% reason or 50% contribution of humidity for the rusty jobs, 50% contribution, humidity is contributing 50% or 49%, and other factors are 50%. I need to check that factors, but I can tell that if I make a square of this R value, it get R square. It means rust, percentage of rusty jobs, and the reason for it 50% is the humidity. Clear? So scatter diagram used in industry when you have the data and when the data is variable, you can just plot the relationship. In one of the Six Sigma Yellow Belt project, when we plot the scatter plot and the relationship was not strong. So we can conclude that this is not the reason because R there is almost very low correlation. So this is the
Sir,
not the reason, main the reason for this problem. Got it?
sir, sir, what is the correlation in between to doing that square with the correlation?
Pardon?
What is the correlation in between that? Why we need to do the square?
For
Not
getting the
No, so this is the
percentage.
this is statistics. In statistics, we need to calculate R. So my first
sir,
question, are you understand how to calculate R correlation?
yes, sir. Yes, sir.
Okay, so just do it exercise tomorrow. Just take any data and plot R value. So what does it mean when you square it? What does it mean? In statistical, it is proven that 88%, for example, rusty job is because of humidity. So when you square it, so that is means it gives this direction. For example, here 50% humidity will contribute. Means for rust, I need to work on another parameters as well because only 50% contribution of humidity. So other 50% are I need to investigate what are the other causes. But here I can directly claim that 88% reason is the humidity. So this is the statistical formula. So that correlation, when you square it, so what does it mean tentatively? Main humidity is contributing a lot. Here humidity is not contributing a lot. So there are other parameters as well.
Sir, one thing is that instead of two, can we go for more number of variables?
No, it is used for only two variables. That is,
Two
it is very
variables.
simple. It is not hyper statistics. I'm again telling you, 7QC tools. These are very simple tools. Even your operators, even your supervisors can use. And for example, if you have any doubt, for example, this is the reason for this defect or not. But firstly, not defect, dimension, because first criteria is all the two should be the variables. So there should be variables. For example, the length and the oven temperature, or oven temperature and the hardness. So we can measure it. So there should be variables, and prima facie we need to check whether this variable is affecting or not. So for that you can use a scatter plot. It will just give you the clue how it is affecting it. So you can say that no, that oven temperature and hardness, there is not strong correlation. So I need to investigate other causes. I am again telling you, it is giving you clue whether this X is affecting on Y or not. Clear?
Yes, sir.
Yes or no?
Yes, sir. Clear.
Yes, sir.
Okay. So you can practice it as I'm telling you. This is in this theory, but just take any two variables, plot in Excel, plot the correlation. Just check whether it is a positive or negative. If it is a positive, you can directly say that a positive correlation. But what is the R value? If it is 0.9, 0.951, you can say that very strong positive relation. When R value is 0.5, 0.3, like that, oh, very, very low positive correlation. When the R value is on minus side, you can say negative correlation. And depending upon the value, 0.8, minus 0.1, you can say either a highly perfect or low. Clear?
Yes, sir.
So we have completed the scatter diagram. Okay. So how many tools we have completed till this time? Flowchart,
Check sheet.
check
Flowchart,
sheet,
check sheet, stratification, scatter diagram.
stratification,
Scatter
and
diagram.
scatter diagram. Clear?
Yes, sir.
So what is scatter diagram? It is used for attribute data, true or false? My question is, scatter diagram is used for the attribute data, true or false?
False.
Clear na? It should be used for the variable data. Okay. And if R value is 0.3, whether it is a positive correlation or negative correlation?
Low positive
Sir,
correlation.
no positive.
Low positive, correct? When R value is minus 0.98, whether it is a strong positive or a negative?
Perfect negative correlation.
And
High.
perfect negative. Got it, na?
Yes, sir.
Yes. So these are the simple tools, guys. These are no hi-fi statistics. These are just used on the shop floor. Again, that control chart. Control chart is a separate 4 hours topic. But when we conduct training on 7 QC tools, that depth of control chart is not expected. At least you should aware of the 7 QC tools, how to use it, particularly control chart. There is a separate 4 hours training for that. But here, at least you need to identify how to use check sheet, how to use the flow chart, what are the symbols, then what is the scatter diagram, what is the stratification, what stratification means, what is scatter diagram, it is used for variable data or attribute data, how to find the correlation. So I showed you the how to calculate the correlation formula, and depending on the value you need to predict whether it is a positive or negative, whether it is strong, medium or low. Clear?
Yes, sir.
Yes. So almost 50% tools we completed. Okay. Now we will go to the tool number 5. And this is called as Pareto chart or Pareto diagram. Okay. What do you know about Pareto chart or Pareto diagram? Can anyone tell me what is Pareto?
Yes, sir.
Who was he?
Pareto
Basically,
means
Pareto,
80% of our
the Pareto,
directly
80-20
20%
rule.
of our effort directly linked to 80% of outcomes.
First, let me know who was Pareto. Who was Pareto? First, give me answer of that question. Who was Pareto?
Pareto was a quality guru.
Pareto was not a quality guru. Who was Pareto? Any idea who was Pareto?
No, sir.
And why this Pareto principle used in quality? Any idea?
Yes, sir.
If no, let's go to the next slide. Okay, I will go to the next slide. So what is the history? So let's go through the history first. Pareto, the name is Wilfredo Pareto, and he was not a quality guru, he was not a quality consultant or author. He was an Italian economist, Arthashastri in Hindi. So he was an Italian economist and he developed the Pareto principle. As he was economist, he studied the economy of Italy, and he was also the first to claim that income follows a Pareto distribution. What that Pareto distribution? Explained in point number 4. So in 1906, he made his famous observation, and that observation is called as Pareto principle. When he studied the economy of his own country, that is Italy, and his observation was 20% of the population, 20% of the population has 80% of the wealth, and 20% of the wealth is distributed among the 80% of the population. So I will once again repeat, Pareto was an Italian economist and he is famous because he developed the Pareto principle. What that Pareto principle is, or Pareto principle, or his famous observation that 20% of the population has 80% of the wealth. So this is the richer category. 20% of the population. In population, they are 20%, but 80% of the wealth, they are owning the 80% of the wealth. So let me ask you a question. This was the observation for Italy, but is this the applicable for India as well?
Yes, sir. It is applicable in India as well.
Yes, it is applicable to any country. The 20% of the population of any country. So I'm not exactly putting 20. Sometimes it will be 15, sometimes it will be 25, sometimes it will be 30. But few people of the country owns most of the wealth of the country. So 20% of the population of India, for example, and they are carrying 80% wealth of India. And 80% of the population normally carry 20%. And just check in your industry as well. Don't mind, but 20% of the people, they have the 80% of the salary. Suppose monthly salary, drawn salary. So 20% of the people has the 80% of the contribution, and 80% of the people has the 20% contribution. So casual workers, they will be very high in numbers, but salary will be very less. So this is applicable everywhere. This is called as Pareto principle. Clear? Pareto principle is clear?
Yes, sir.
Yes, sir.
Who introduced the Pareto principle?
Wilfredo Pareto.
Wilfredo Pareto.
Italian
Wilfredo
economist.
Pareto, he developed the Pareto principle, and what his famous observation was, and he made this observation. Actually, he studied, I think, in 1896 or 1897, but officially, he declared in 1906 that 20% of the population has 80% of the wealth. Now, that principle is known as Pareto principle. And now, let me ask you a question. Why this principle is used in quality? So somebody was asking me, what is the relevance of scatter diagram in quality? So now I am asking you, what is the application of Pareto principle in quality?
Sir,
Why this principle is used in
sir,
quality?
for every item, 20% will be always, it will be a good quality, and 80% thing we have to check 100%.
Sir, it's my
Can
simple
any
answer.
other one can speak?
To reduce
What
the
is that?
adjusting percentage, a simple way.
Okay.
80%
Can you please tell
problem.
me in that 80-20 manner?
Sir, 80% problems are due to the 20% reasons.
Okay.
20% of defect category will
Okay.
be responsible for the 80% of the total.
80% of the
Yes. So I can say
rejection.
that, for example, 80% of the revenue of any company will come from the 20% of the customer, and 20% of the revenue will come for the 80% of the customer. Hello, who is speaking?
Hello.
Hello.
Sir, please mute everyone.
Please. Okay, I have muted everyone. Huh? So, hello. He was an Italian economist. He developed the Pareto principle. He studied the economy of Italy, and he was first to claim that income follows the Pareto distribution. That is, 20% of the population has 80% of the wealth. Now, our next topic of discussion is why it is applicable in industry. Okay, so let me explain the next slide. So, he is famous quality guru, and the name is Sir Joseph Juran. He was a quality guru. As I told on day one, he contributed a lot in improving the quality of Japanese products along with Dr. Edward Deming. So Edward Deming and Joseph Juran contributed a lot in the Japan's quality transformation. So Joseph Juran was a quality guru, consultant, author, and he used the Pareto principle in the field of quality. And he was aware about that Pareto principle, even though that Pareto principle was used for the economy. He decided to use it in industry, and he named this principle as 80-20 rule, and he used the term vital few and trivial many. So we will discuss it, what does it mean. And Joseph Juran noted that 20% of the quality problems cause the 80% of the loss. So 20% of the quality problems, 20% of the defects are contributing in 80% of the rejection. So suppose I have 10 defects, then 2 defects are contributing to the 80% of the rejection. So I need to focus on this called as vital few. I need to focus on vital few. So, and hence Juran used the Pareto principle in industry. He named it as 80-20 rule, and he noted that 20% of the quality problems caused 80% of the loss. Or you can say that 20% of your defects out of 10, that will contribute to the 80% of the rejection. Okay, and hence since then this principle, even though Pareto was an economist, not a quality guru, but this principle is used extensively in industry. Okay, so this is the history of Pareto. Now what is Pareto diagram? It is a bar chart, very simple. What is Pareto? It is a bar chart. What it represents? It represents the frequency or impact of the problems in descending order. You will I will take example from Excel, then you will understand. So it represents the frequency or impact of the problems in descending order. It helps us to identify vital few and trivial many. So what is a vital few? We will see in that graph. So what is Pareto? Once again, I will repeat. It is a simple bar chart. Again, I am telling you, it is a visual tool. So the beauty of quality tools is these are the visual tools. So it is a bar chart. It is a visual tool, and it represents the frequency or impact of the problems in descending order. It helps us to identify vital few. Okay. When to use Pareto diagram? When you would like to grab the attention of the management for the important problems. As we discussed, 20% of the defect will contribute to the 80% of the rejection. So you can grab the attention of management while putting the Pareto diagram, and you can tell the management, these are the 2 defects I need to work, because these 2 defects are contributing a lot in my rejection. And if I would like to reduce the overall rejection of our plant, then I need to focus on these 2 or 3 defects, because as per Pareto principle, they are contributing a lot. Okay. We also use the Pareto diagram to set the priorities for selecting the projects. So we need to work on this, for example, crack percentage rejection, because percentage reduction, because this is contributing a lot in rejection. So I can identify the projects based on Pareto diagram. I can select a project. It is very easy me to select a project. Suppose new engineers have joined, I can allocate him or her a project. Depending on the Pareto chart, I can tell him that you need to work on the reducing the crack percentage rejection. So it helps me to set the priority for selecting a project or projects. And when we have to take a decision in quality control as well as the process improvement, which process we need to improve, on which defect we need to work, then we can use the Pareto chart. Okay. So this is about the history of Pareto chart. What does it mean and when to use this? I am again repeating. So history is, Pareto was an Italian economist. He noticed that 80% of the wealth belongs to only 20% of the people. Okay, and this is called as Pareto principle. Mr. Juran, who was a quality guru and consultant, he named it as 80-20 rule and used this terminology first time in field of quality, that Pareto principle. And he used the term vital few and trivial many. So what is vital few we'll discuss later on. And he noted that 20% of the quality problem caused 80% of the loss, or 20% of the defects causing the contributing to the 80% of the rejection. Okay. What is a Pareto diagram? It is a bar chart and it is a visual representation of the frequency or impact of the problem, and it helps to identify vital few and trivial many. Okay. And when we would like to grab the attention of the management, when we would like to select the priority for the project, and when we have to take a decision which process I need to improve, which defect I need to work on, we can use Pareto. Okay. Now, how to construct a Pareto chart? Instead of describing here on PowerPoint, I will use Excel how to construct a Pareto chart. Okay. So can we go to Excel? Please type yes if it is understood the concept of a Pareto diagram. So can I use Excel to elaborate?
Yes, sir. Yes.
Yes, sir.
Okay. So before that, please let me show you how the Pareto diagram looks like. So this is the Pareto diagram. When I collected a defect, so these are the defects, and I came to know that 1, 2, 3. So suppose this is 80%. So this is the 80%. These are, I draw a line, and here I came to know that it touches here, and I again draw this line. So I came to know that these 3 defects contribute to the 80% of the rejection. So I need to focus either on this, or either on this. You can start with this or this. So these are the vital few. So this is called as Pareto chart of defects. So how to draw these? These are called as vital few. These are the very few, 1, 2 or 3. These will be many. So it is 1, 2, 3, 4, 5, 6. Here may be 7, 8, 9, 10, 11, 12, 13, 14. It may be many. But this we need not to focus here. We need to focus on vital few. This is called as 80-20 rule. Please let me know, let me tell you, sometimes it may be 70-30, not exactly 80-20, 70-30 as well. So thumb rule is 80-20, but it may be a 70-30 as well. Need not to be 80-20 always, correct? So now we need to construct this diagram by using Excel. When you have minute tab, you can draw it in a minute. But we will see how to plot a Pareto by using Excel, because these are the basic quality tools. We are suppose that we are not using any Minitab here. we will learn how to draw the Pareto in Excel. Very simple. Okay. Now I will go to the Excel. I need to draw this. Okay. Now let's go to the Excel. Okay. So this is the Excel. I already draw and I pasted it in PowerPoint. But let's do exercise. Okay. So this is the type of defect and this is the quantity in numbers. So this is the data collected with the help of check sheet. Normally, I give check sheet to young quality engineer or supervisor and I tell him to collect the data of the rejection. So suppose he collected data for the 7 days by using check sheet. Okay. Now, and he presented this data to me. Okay. I will just calculate the summation here. Okay, means there are 170 numbers is the rejection. Okay, so this is the data given by somebody. Suppose I call it as Akash. So Akash, he's a quality engineer, and I told him that please collect the data by using check sheet and please present this data to me. So he came with this sheet. Sir, this is the thread damage 46 numbers, damage job damage 28, pinholes 51. You can put your defects. No? I have used the defects from the die casting industry. You can put your own. Blister is 2, shrinkage is 5, OD size less 10, OD size more 13, like that. So Akash came with this sheet. Okay. Now I will train Akash to plot a Pareto. Okay. What I will do, I will tell Akash, now Akash, you done a very good job. You collected the data. Now just arrange the data in descending order. Okay. What Akash will do, I will tell Akash, just go here, click here, go to the data. And this is Z to A. Okay. Why it is coming? Why it is not coming?
Sir, you have to go and select the sort.
No, I did that.
No, no. You have to go to sort.
Sorry. Oh, I need to select this.
You have to select
Data. Sort. Sort. Okay. Got it. So this is the total I need to delete. Okay. So first, I told Akash that you need to arrange the data in descending order. Okay. Now I will calculate here the total rejection. Okay. Now rejection percentage. I need to calculate the rejection of percentage for this divided by this. I will put $sign here. So it is 30%. Okay. So this is the rejection in percentage. Total should be 100. Yes, 100 is clear. So I told Akash, first step is, this is, I will write here first step. First step is, I told Akash that please arrange the data in descending order. Okay. Now I told Akash, now calculate the rejection percentage, individual rejection percentage. So pinhole rejection percentage is 30% because total is 170. Thread damage is 27%, damage is 16%, OD size is 8%, like that. So I tell these two steps to Akash. So Akash told me, yes, sir, these two steps are understood. What is next, sir? So I told him, now calculate the cumulative percentage. How to do that? this plus this, enter 57. Okay, it should come 100%, means we are clear. So summation of this should be 100 and here 100 should come. Okay, now I told Akash this is step number 3. Akash is very happy now because he is a young engineer and he doesn't know about the Pareto. What does it mean? So I told him the history, that who was Pareto, how he developed, why this is used in quality field. Now I tell Akash that collect your data. First step is sort your data in descending order. This step is done, so I will make it as a green. So Akash did it. Okay, very good. So this also Akash did it. So this is also green. So Akash did these 2 steps. Okay. This also Akash did. So I will again make it as a green. So this is done by Akash. Now Akash need to plot a Pareto. He will select all this data, insert and bar chart. Okay. So this is the bar chart. Okay. I told you Pareto is a simple bar chart, but what is difference? I will let you know. So we calculated cumulative as well as the rejection percentage. For example, I don't know the rejection right now, so I can delete rejection. I only need cumulative. Okay. Now these are the cumulative percentage and these are very small. Okay. So I will right click here, format data series, and I can plot secondary axis. Okay. So this is the secondary axis. And I selected this secondary axis. Okay, this is the secondary axis. I selected this. I will go to the home, insert. There will be some lines. So, okay. So you can name the chart. For example, defect. Pareto chart of defects. Okay. So this is the line. You can make it a red. It is up to you. Okay. Then we need to display the values.
Sir, is there any specific name for that line or else it's just trend line?
Pardon?
Yeah, here we highlighted in the red color, right? The trend line.
No, there is no color. I just highlighted by red. You can use your own.
No, sir, no, sir. I'm telling, is there any specific name for that line or else it's just
No,
trend
this is called as this is the cumulative percentage line.
cumulative percentage
So
line.
it is increasing from this to 100. It will reach to 100 and it start with from this. So it will reach to, this is called as cumulative percentage line. Okay.
Sir, if you don't
Now,
mind, can you repeat this cumulative percent, how you draw?
Pardon?
Can you repeat this cumulative percentage line, how you draw this?
Okay. I will once again draw it for you.
Yeah,
to entire.
please. Thank you.
Okay. So I will select, correct? It is clear, selection?
Yeah, clear?
Yes, sir. Clear, sir.
Insert. I will go here and I will plot this. It is clear?
Yeah, clear.
It's a bar graph.
So now this is the bar graph, simple bar.
Yeah.
Actually, in minute tab, you will get it in minutes, but this is the traditional method. We need to have it. So now this very small. These are the cumulative percentage. It is showing here. These bar graphs are more because it is percentage and these are in numbers. So now I need to select this small cumulative. For example, I selected this. Selection is clear?
Okay. Yes.
Now right click, go to the format data series and click secondary axis.
Okay.
Right click, go to the format data series, click secondary axis. Okay.
Clear.
So this will be in graph form, but we need in line form. So I check here. I will again go here, insert. I will use this one. Okay. So this is the line.
Clear.
So I will not waste time. You can plot the chart title, Pareto for defects.
Yes,
Okay.
sir, yes.
Clear.
So because we have or where Pareto I will name Pareto for defects. You can put it the x-axis, y-axis. We will not waste time in that. Okay. Now this is the line. Okay. So I will make it a red, for example. You can use any color. So I made it, for example, red. Okay. Now I need to display the data labels. So format data series, data labels already plotted. Suppose I should, and the above, I will click above, will go above. Okay. Now I need to do for this as well. So add data labels. Very good. So my Pareto chart is completed. So you can name this Pareto of defect charts. You can name it as the quantity in numbers. You can name it here defects, because I will not waste time. You can name a community in percentage. Ideally, in Excel, it is like that. So in Excel, it is like that. So you can reduce the grid lines. For example, reduce the grid lines. Okay. And in when you draw in Minitab, there should not the gaps. These gaps are not there. So how to do that? You can select it. Go to the format data series. Gap width, make it 0. 0. And here series overlap, make it 100. Then you will get the graph like this, like in Minitab. Okay. Now select this, because I need to set the boundaries. For example, home or format. Okay. So our Pareto chart is completed. Got it?
Yes, sir. Got it.
Yes or no?
Yes, sir.
This is the same as like this. Now you can draw this line at 80%. I'll draw this line. At 80%, I draw this line where it is intersecting. Oh, here it is intersecting. So this, and I need to again draw this line, vertical line, like that. So now these three defects I need to focus. That is called as vital few. Got it? So you can start from 70% as well, but normally it is 80. 70% you can write. So I need to work on 80% problem. 80% contribution factors. Clear?
Clear, sir.
Yes, yes, clear.
So now you can present this to the management, and you can tell that, sir, one person is already working, suppose, on pinholes. Then you can say, Akash, you can work on thread damage. So somebody is working on thread damage as well. Then I tell Akash, please work on part damage. So because it helps me to take a decision. That is called as Pareto chart. Very simple. In Minitab, it will be drawn in seconds. But here I explained you traditional method, because normally it should be used by the shop floor people. So are you clear, friends?
Yes,
or
sir.
no?
Yes, sir. Yes, yes, yes.
Yes, sir.
Very simple.
Yes, sir.
Very simple. Okay. Now we will move to the next tool. I will cover in 5 minutes just a history and how to draw, and the example we will see tomorrow. Okay.
Excuse me.
So
What
Pareto
is
chart is
Minitab
clear.
that you're talking about?
So just a recap in 2 minutes. Who invented Pareto principle?
Sir, I'll interrupt. What is the Minitab that you're talking about?
Wilfredo Pareto. Was it quality guru or economist?
Economist.
He was economist.
Sir.
And what was his
Italian
famous
economist.
observation?
20% of the population has 80% of the wealth.
2080,
Is it
sir.
applicable to India as well?
Yes, sir.
Yes, it
Of
is
course,
applicable
sir.
to. Okay. So now why this principle used in quality? Who used this principle in quality?
Joseph
Joseph
Juran.
Juran.
Mr. Joseph
Joseph
Juran.
Juran. Because he was very talented
Juran,
guy, and
Joseph
he came to
Juran.
know that yes, this principle can be applied in quality. Means my 80% rejection is contributed by only about 20% of the defects. So I need to focus on vital few, and hence he developed this tool he called as 80-20. Then we learn how to draw the Pareto. First, collect the data. Here I mentioned the sequence. Collect the data, select the event. For example, I am selecting the event of the rejection, defects to be analyzed. Collect data on problems, preferably use a check sheet. Select the categories, highest to lowest, sort. Then calculate percentage of each category, calculate cumulative percentage, and complete the Pareto chart I explained in Excel. Clear?
Yes, sir.
Yes.
Yes, sir.
So now we will discuss on the cause and effect diagram. Okay. Now we
Excuse me,
will
sir.
just see the yes.
Sir, you are telling about Minitab. What is it?
So Minitab is a software. Mostly it is used in Six Sigma. It is a I am also not using too much Minitab, even though I am Six Sigma black belt, because it need a license copy. So Minitab is a software and it help you. These diagrams will be drawn in seconds. So just select the data and select the Pareto. It will come automatically. You need not to do it in X.
Okay, sir. Thank you.
Okay.
Okay.
Now we will see the cause and effect diagram. Okay. So before going to the cause and effect diagram, I will explain you the brainstorming and then I think we will see it tomorrow. Okay. Now I will explain the brainstorming while doing the diagram. Okay. So history of Ishikawa diagram is, as I told, Ishikawa did a major contribution in the quality transformation initiative of the Japan. So Mr. Ishikawa developed this diagram in 1960s and he used this diagram to identify the possible causes or called as potential causes of a specific problem. What is possible causes means? Means we are not sure that this is the reason for this problem. I may think that this might be the reason. So that is called as possible causes. So possible means while doing a brainstorming or while discussing with the CFT members, I tell them, for example, I am getting a very poor mileage of my TVS Jupiter or my bike. So what do you think? What are the reasons? So they will tell lots of causes. So these causes are called as possible causes or potential causes. They may contribute to the less mileage of my Jupiter or less mileage of my bike. But currently I'm not sure. I'm just collecting ideas from them. That is called as potential. The word potential means currently I am not sure whether these are the reasons. I'm just categorizing, or sorry, I'm just collecting the potential or possible causes. Okay. So that is a history. First time Mr. Ishikawa used this diagram in Kawasaki shipyards. So Kawasaki is a Japanese company, and first time the fishbone diagram is used in Kawasaki, and it became popular in other industries, including automotive manufacturing. For example, Mazda. Mazda is the company, automotive company who first used the Ishikawa diagram. So it is a visual tool to explore the causes of the problems. Okay. So what is Ishikawa diagram? Ishikawa diagram is invented by Karo Ishikawa or developed by the Karo Ishikawa in 1960, and it is used to identify the potential or possible causes of a specific problem or event. I am again repeating, potential and possible means I am just collecting the ideas from the people. I'm not sure whether this is the cause or not. Suppose I may get 40 causes and because of that I'm getting a less mileage. But I need to select the which are the significant causes. Significant causes means because of that causes my mileage is coming down. So right now I don't know what are the significant causes. I need to collect all the possible or potential causes. Then I will explain you how to go from the possible to the significant. First, remember that we need to collect possible or potential causes, and for collecting potential and possible causes, Ishikawa diagram is very helpful. And this diagram is invented by Karo Ishikawa. First time he used in 1960, and the industry, the name of industry is Kawasaki, or the name of group is Kawasaki Group, and later it is popularized in automotive manufacturing as well. Mazda, the company who used the Ishikawa. Okay. Now, what is Ishikawa we will see. When to use Ishikawa we will see, and how to draw Ishikawa we will see it tomorrow. What is Ishikawa diagram? It is the visual representation. I like one fact or I like one point about the quality tools. These are the visual representation most of the times. So Ishikawa diagram is a visual representation of the relationship between whom? Between event. Event is called as problem. Here my problem is my bike is not giving a good average or a poor mileage. So this is the representation of the relationship between problem and all the possible causes. I am once again repeating. Ishikawa diagram is a visual representation of what? Relationship. Of what? Event or called as problem. Relationship between problem and possible causes. And Ishikawa diagram explain me that relationship visually. So what is Ishikawa diagram? Ishikawa diagram is a visual representation of the relationship between the problem and the possible causes. Okay? It looks like a skeleton of a fish and hence it is called as a fishbone diagram. Okay? Why it is called as a fishbone? I will explain. It looks like the skeleton of a fish. So this diagram has three names. One name is Ishikawa diagram. Why Ishikawa? Because Karo Ishikawa developed this diagram and hence the name is Ishikawa. Second name of this diagram is called as fishbone diagram. Why fishbone? Because it looks like a skeleton of a fish and hence the name fishbone. And third name is cause and effect diagram. So why cause and effect diagram? Because it shows the relationship between causes and the effect or the causes and the problem. Effect is also called as a problem. It shows the relationship between causes and the effect and hence the name is cause and effect. So it is clear. This diagram has three names. Ishikawa because Ishikawa developed it. Fishbone because it looks like a fishbone. And third name is cause and effect diagram. It shows the relationship between visual representation between causes and the effect. Clear?
Yes, sir.
When to use Ishikawa? When we are listing down all the possible causes which are affecting the problem. I don't know out of these possible causes which causes are significant, but firstly I need to list down all the possible causes. That is first. Second, when the causes are often based on 6M, means we know that the problem for this is from the 6 causes. 6M means man, machine, method, material, measurement, and mother nature. So these are called as 6M. It is said that all the process related problems mainly came because of 6M. Either it is a problem of man, whether it is not skilled, not trained, or otherwise it is a problem of machine, otherwise it is a problem of material, otherwise it is a problem of method, how I am working this or SOP or work instruction. Either it is a problem of measurement or either it is a problem of mother nature. So when to use Ishikawa diagram? When we want to list down all the possible causes. When we
sir,
know
what is
that
mother nature?
the mother nature means environment.
Okay.
Environment.
When causes are based on 6M, so then we use the Ishikawa. 6M means man, machine, method, material, measurement, and mother nature. Okay. So Ishikawa normally identified that any process related problem is normally because of 6M. And you need to check which M is contributing more. Either it is a man is contributing more or machine is also contributing, man is also contributing, and material is not contributing, method is not contributing, or man is also contributing, machine is also contributing, or material is also contributing. So this is the diagram. Normally, it is called as cause and effect because causes are related to the 6M and these causes are affecting the problem or effect and hence the name is cause and effect diagram. Clear? So I will just show you the diagram and how to construct it we will learn tomorrow. So this is called as cause and effect diagram or fishbone diagram or Ishikawa diagram. So this is called as problem. The problem is also called as effect. Problem is also called as result. And these are called as causes. So causes are 6M: man, machine, method, material, measurement, mother nature. As these are the causes and these are the effect, this is called as cause and effect diagram. It looks like a skeleton of fish, hence it is called the fishbone diagram. And it is developed by the Karu Ishikawa, and hence it is called as Ishikawa diagram. Clear?
Clear, sir.
Yes, sir.
So
Clear.
these are the causes. This is the process. Suppose our die casting process or any pizza making process, and this is the problem. So there is a rejection. Crack is the rejection, or my pizza is not tasting well, and this is the effect. And this effect is because of these causes. Always remember, this part is called as result or effect. So this pizza is not tasting good. Why pizza is not tasting good? Because of either man, material, measurement, environment, method, or mother nature. My tea is not good. Why not good? Either it is because of man, machine, method, material, measurement, mother nature. My mileage of a bike is problem. Why? Either it is because of man, machine. So these are the causes. This is effect and hence cause and effect. Clear? So we will stop here. Tomorrow, in first 20 minutes, we will learn how to consider cause and effect diagram. Then for 20 minutes, we will discuss on histogram. And then for almost 35 or 40 minutes, we will discuss on control chart. Clear?
Clear, sir. So tomorrow will be the last day of the training, right, sir?
Tomorrow. And tomorrow we will cover, because these are the main, we will almost cover the 5 and 6 we already started. So it will take only 15 minutes to complete cause and effect diagram, because we need to learn how to draw, and then we'll focus on histogram and control chart.
Yes, sir.
Clear?
Yes, sir.
Clear, clear.
So can we stop here now? Can we call it a day?
Okay,
Yes,
sir.
sir.
Okay.
Okay.
So tomorrow, please be on time, because we have last day tomorrow, and I will give my mobile number in chat box. Please text me if you have any queries. This is my WhatsApp number. My number is 9763. I am putting in chat box. So my name you know, but I'm again
Sir, one
Hiranyesh
second.
Pandit. This is my mobile number.
9763. Hello, sir. 9763.
727417. I mentioned in chat box. Welcome all. Welcome all.
Thank you, sir.
So good night all.
Yes, sir. Thank you.
Thank you, Manjula. Thank you, Subra.
Thank you, sir.
Thank you. Good night.
क्या नंबर दिए
So please mention in chat box whether you like this today's session or not.
हेलो
Yes.
So after completion of the session, like 5 days training, how we'll achieve our certificate?
I think it will take 15 days.
So it is on the basis of attendance, or we'll have to give some exam?
No exam. No exam is there. It's based on attendance only.
Okay, got it. Thank you.
Have you understood today's session?
Yes,
Thank you.
thank you.